See, funny thing is, I would say third time's a charm, but this is actually probably my 5th time recording this. So, I don't know, I just want to explain it right and good. But, my name's Matthew. Welcome back to another video. Today, I'll be showing you something really interesting. If you like math, if you like just thinking about the world, you'll love this. So, I've been reading a book called The Grapes of Math. It's by a guy named Alex Bellios, I think. Apparently he was on Numberphile, maybe. My friend told me that. I could be wrong. But in it, he talks about really interesting proofs. He talks about really interesting concepts just to kind of, that nobody talks about, right? He shows these things that amaze me. For instance, in your everyday life, every number that you look at, 31% of the time, it starts with a 1. I think it's 31% of the time. It starts with a 1. That's pretty whack. But we'll get into this. So this video is going to be talking about how to find the height of a mountain by looking at it from 2 different places. Let's begin. Landscape. Mountain. Looks pretty symmetric. That's what I said last time. I don't know why I said it like that. So this is H, right? And you measure the height of a mountain at the peak. So that's why it's at the peak right there. And just for convenience, we'll just call this point C. You'll see why in a bit. C, get it? You'll see why. I didn't actually plan that. I just made it up. So let's say you go to point A. You're at point A, right? And you look up at this mountain. And you're like, dang, that's one tall mountain. How do I find out how high it is? So you look up at it. I'm joking, I don't know. And you look up at an angle called alpha. Now this alpha is something that you can actually know. So this is you. This is like the horizontal. This is your eyeball looking up at the mountain. This angle you can know because there's some tools out there to measure up how high something is based from the horizontal. So like, I don't know how to do it. I didn't really look into it, but you need it for triangulation and like other stuff for navigation. So you definitely can. Excuse me, I just burped. But from this point A, all I'm trying to say is you can find this angle out. So from point A, you tootle on about X distance to go to point B. Alright, horizontally, like in line with it. And now, I guess you don't really have to be in line technically, but besides the point. So you can look up B to the peak, from B to the peak, new place, new angle. So we'll call it angle beta. This distance from B to C we'll denote with L. Therefore, this distance from A to C is L minus X, because this is that smaller distance here. Do you see that? So that's L, and that's L minus X. I think you should grasp that. But, notice, you can write down some cool, you should probably write down some functions for that taken angles, because you know what these angles are. You should use them to your advantage. So we know that tan beta is equal to, well, tan, of course, is opposite over adjacent, so katoa. And the opposite is H. And the adjacent, well, this big length here, L. Correct? Now, we also know for the other angle, tan of alpha, well, that's just equal to H over L minus X. Because H is opposite, L minus X is adjacent. Don't mind this stuff. I was running out of pieces of paper. I'm just making excuses. I could have grabbed another. Save the planet, right? So now let's rearrange both of these equations for H. And then we could smash them together and get rid of H. I think that's a pretty good plan, eh? So L minus X tan alpha. Sorry, Should keep it on screen. I'll get better at this. So I just brought that over there, the solve for h. Now let's smash these boys together. And we'll get L times tan of beta is equal to L minus x times tan of alpha. Which is, well, let's take it slow. Multiply this tan in L. Tan of alpha minus tan of alpha here. So we know what x is in this. So let's try solving for L, because we have no clue what it is. Let's just solve for it and see what we can do. So bring this x to the other side. And bring this to the other side and divide and bring this to the other side, factor out the L, so then it's just tan alpha minus tan beta that will be on the bottom here. Maybe I didn't explain it right, but that's how you rearrange it. Okay. Okay, now let's take this rearranged form and note, look at this guy right here. Well, h is equal to L times tan beta. Well, we have L right here, so let's plug in L there. Tan alpha all over tan beta, all times by tan beta. Well, that's actually it. You literally with this formula, you literally could calculate the height of this mountain just by knowing this angle, and this distance. Super easy to show, super easy, just food for thought. You know, when you're out mountain hunting and you gotta pick up the highest mountain, just use trigonometry. That's all I'm trying to tell you. I'm kidding. Okay, thanks for watching.